Hi, sixth graders. Here's today's math lesson on interpreting inequalities. So we've spent time writing inequalities, graphing them on number lines. Today we're going to think more about what these inequalities mean in real world situations. So for today's lesson, you will need your computer and you will also need your math spiral and a writing tool. Ready? Here we go. So today we're really thinking about, let's examining what inequalities can tell us. What do they mean in the real world? So our goals include, I can explain what the solution to an inequality means in a situation, and I can write inequalities that involve more than one variable. So by the end of today's lesson, we're hoping to be able to do both of those things. Let's start with a warm-up that kind of brings in some prior knowledge. So we have true or false, fractions, and decimals. You're going to be seeing three different equations, and you need to decide, are they true or false, and explain your reasoning. So here's our equations. Number one, 3 times 12 plus 5 is equal to 3 times 12 times 3 times 5. Number two, 1/3 times 3/4 is equivalent to 3/4 times 2/6. And number three, 2 times 1.5 times 12 is equal to 4 times 0.75 times 6. Now, before you jump into these and just simplify both sides, I really encourage you to think about the properties of operations we talked about earlier in our algebra expressions unit. You have a foldable in your notebook that looks like this. This might help you identify some properties you could use without having to fully simplify both sides. Please work through numbers 1, 2, and 3 on the next page of your spiral notebook. Pause the video while you're solving. Then when you're done solving, you can continue to play the video to check your answers. Here's the answer key. Number one is false, and the property that would help you with that is the distributive property. Number two is true. You could have used the commutative property of multiplication. And then number three is false, because we'd use the commutative and associative properties to simplify, and notice that you have 24 on both sides and it's being multiplied by two different amounts. Please take the time to read through this entire answer key and check your own work. So make sure you pause the video. Once you're done reading the answers and checking your work, you can continue the video. So now let's apply our work on inequalities to one real life scenario. It's about a basketball game. You're going to complete this entire task in your spiral notebook. So Noah scored N points in a basketball game. That's our real world scenario. So what does 15 is less than N mean in the context of the basketball game? So if Noah scored N points, what would 15 is less than N mean in this real world context? Number two, what does N is less than 25 mean in the context of the basketball game? So what do these two inequalities tell us about how many points Noah might have scored? You're going to draw two number lines to represent the solutions to the two inequalities. So you need a number line with a circle and an arrow to show 15 is less than N, and a second number line with an arrow and circle that shows N is less than 25. Number four, you'll name a possible value for N that's a solution to both inequalities, 15 is less than N and N is less than 25. Number five, name a possible value for N that is a solution to 15 is less than N, but not a solution to N is less than 25. And then in this basketball game scenario, can -8 be a solution to N? In this context, explain your reasoning. So please pause the video and answer these 6 questions in your spiral. Once you've answered them, you can play the video to check your answers. Here's the answer key for those 6 questions. Please pause the video to check your answers. The next activity we're going to try is something called unbalanced hangers. So I want to show you a picture. This is a balanced hanger, and we've seen this earlier in our algebra unit. You can tell it's balanced because this gray bar at the top is going straight across, and it shows that both sides have an equal value. So in this example, these 4 orange circles have the same value or the same weight as 1 orange circle and 2 blue triangles. So this is an equation because both sides are equal. Now with inequalities, we're going to see unbalanced hangers. This side, this left side that's tilted downwards, is the heavier side, or it has the greater value. So 4 orange circles in this example is greater than 1 orange circle and 2 triangles. So an unbalanced hanger means we have an inequality, 2 values that are not the same. So keep that in mind. Please complete this task in your spiral. Notice that, for example, question 1 talks about this diagram with a pentagon, this yellow shape, and a circle here that's red. You have 2 questions about that unbalanced hanger, and then you can go on to step 2. It has a new hanger, steps A, B, and C. Step 3, you're thinking about the relationship between this blue square here in number 2 and this red circle here in number 1, since they're both being compared to the yellow pentagon. And then here we see the same 3 shapes on an unbalanced hanger, and you're thinking about if the inequality here is true. And then number 5, you're actually going to draw your own hanger to represent this scenario, where S stands for the square, C stands for the circle, and T would be the weight of a triangle. So you have a new shape to draw. So please pause the video here. Please solve these in your notebook, and then you can go on to check your answers when you're done. Here are some possible answers. There are more than one correct answer to these, so if you have questions on whether or not your answers are correct, please contact your math teacher to check in. Once you're done checking your answers, you can continue on in the video. Please press pause if you need to. Okay. Here's one last practice task. You have a picture of a balanced hanger. So we have an equation here. It shows the total weight of the 3 green triangles is the same as the total weight of the 4 squares. Now from this balanced hanger, we're going to reason, what does this tell you about the weight of 1 square when compared to 1 triangle? So which do you think would be heavier, 1 triangle or 1 square? And how do you know? And then write an equation or an inequality to describe the relationship between the weight of 1 square and 1 triangle. Let S be the weight of a square and T be the weight of a triangle. So you're going to capture your thinking from step 1 in either an equation with an equal sign or an inequality with greater than or less than for number 2. Please pause this video, answer both questions in your spiral, and then continue on to check your answers. Oh, sorry. Let's pause to check the answers. Sorry about that. So here was the task we were just working on, the triangles versus the squares, and here's the answer key for that one. So please check your work. So just to wrap up our lesson and thinking about inequalities in real-world situations, let's move through a quick synthesis together. So I want you to think about a situation where a limit or a range of values can be important, like keeping people healthy or safe. So my example is on the freeway, to keep people safe, you should drive between 55 to 70 miles per hour. You might also think about how many people should get on an elevator. You might think about how many calories someone should consume in a day to have a healthy diet. So now we're going to think about, in that real world scenario you just picked, how can you define the variables in it, the amounts that can change, and then write an inequality to represent that situation. So in my example on the freeway, I'm going to say let Y represent a driver's speed. That's me defining my variable. So my inequality would be that 55 is the slowest you should drive, and that's less than or equal to Y, the driver's speed, and Y should be less than or equal to 70, which is the maximum speed you should drive. I could have also written two inequalities and said 55 is less than or equal to y, and y is less than or equal to 70, but I combined them into one here. Now I want to think about, do solutions that are not whole numbers make sense in this situation? So in my example of driving on the freeway, would decimals or fractions make sense? Well, I'm thinking about, you could drive like 59.5 miles per hour, but in most cars, your speedometer, the tool that measures your speed, is whole numbers. So whole numbers overall make more sense, but you could use fractions or decimals if you had that level of speedometer on your car. Thinking about weight on an elevator, you probably want to just use whole numbers so that it's easy, right? Solutions maybe that have fractional or decimal answers might be like the hours of sleep you want to get every night, like 5.5 hours or 7.5 hours or something like that. Then I'm thinking about, in my scenario, do solutions that are negative numbers make sense? Now, in this case, with driving on the freeway, no, you can't drive a negative speed. That's impossible. You're either going 0 or you're going a positive speed. So thinking about what answers are reasonable, I'm checking my answers here by thinking about, do fractions or decimals make sense in the situation? Do negative numbers make sense? I'm identifying more information about my solution. And then finally, do the numbers on the boundary count as solutions? So for example, if an elevator has a maximum capacity of 2,500 pounds, can it safely handle exactly 2,500 pounds? Or is 2,499.9 the limit? In my example, I would say the boundaries can count as solutions because you can drive exactly 55 miles per hour or exactly 70. So the purpose of this is to think about, when you're identifying your solutions to inequalities in a real world situation, you need to check your answer for reasonableness. Does it make sense based on the situation you're working with? So again, today's goals were to explain what the solution to an inequality means in a situation, and to write inequalities that involve more than one variable. And we were able to do that through this practice. So we have a velociraptor celebration here going on. And now it's time to practice. So you're going to be completing the practice problems in your Spiral notebook. There's a PDF of practice problems on the Google Classroom post where you found this video. You're going to check your work after you're done using the attached YouTube video, and then you'll complete the exit ticket, which is attached to the Google Classroom assignment, so we can see how you're doing. Please be sure to press the mark as done button or the submit button when you finish, so you get your points for the assignment. Have a good practice.